Now let's look at what do I mean by components of a vector. So how we have been tracing this is, we started with introduction to vectors, and that was followed by how the 3D space. We looked at how the 3D space looked like, and then we saw how vectors are represented. So representation of vectors is something that we saw. Then we saw types of vectors, the different types of vectors that we had. Then we saw operations on vectors. So these were roughly the topics that we have studied right now. And the components of vector is more or less a part of this representation of vectors, right? We've already seen how a vector is represented, but when we saw the representation, I mentioned the word component there, and we didn't study that in detail. I just told you we'll be coming back to this later. So, but the directional cosines and all that you studied, all of them somehow form the basis of, or they actually combine to form this topic called components of vectors. So components is nothing different, is something that you will realize after you study it once. So let's see, what do I mean by components of a vector? So in order to explain you better, I've taken this image wherein this point P has coordinates 2, 3, 5, right? So I'm taking numerical examples, but ultimately I'll just sort of develop your understanding so that you can do it even without numbers, when you just have variables, right? So this is the point, and like, what is this? This is your origin. So from origin to P, there is a vector OP bar. Now there are a few interesting things about this vector that I want you to observe. So first of all, the things that I would like to highlight here are, this is your x-axis, this is your z-axis, this is your y-axis, right? So your x is here, y is here, z is here. So what does 2, 3, 5 mean? If I say P, 2, 3, 5, what does this mean? I told this to you before as well. 2 means this point P is at a distance of 2 units from the origin along x-axis. So this is distance along x-axis from the origin. Similarly, this is distance along y-axis from the origin, this is distance along z-axis from the origin. So let's look at this on a diagram now. So the things that you can see here, you have this particular point 2, 3, 5, right? So 2 means distance from the origin along x-axis. This point that you see here is at a distance of 2 units along x-axis from the origin, right? Similarly, 3 means at a distance of 3 units along y-axis from the origin, and 5 means along z-axis it is at a distance of 5 units. So now you have 3 vectors here. This is a vector, this is a vector, this is a vector, right? So let this vector be your A, let this be B, let this be C. Now what I want you to know is OP bar that you see here, this OP bar is actually a sum. It is a sum of these 3 vectors A bar, B bar, C bar. This is the understanding that you need to have. So the point is at some random, it's at some random location. You need to know the coordinates of that point, right? Then split the coordinates to create these 3 vectors, like use the coordinates to create these 3 vectors, and the sum of these 3 vectors is your original vector. And these are called the components. Let us now look at how do we represent these components. Now I will bring in those I cap, j cap and k cap in front of you, right? I already told you, I already used this term I cap before, and I told you I'll explain it to you later. I'll explain it to you now, and the way I cap is, j cap and k cap are very similar things. Now let's look at what they are. So in your 3D system, this is your, so let me actually make some space here so that we can just, so I hope you have understood as to how I form the components first. Now we will see how to represent these vectors, how to create, what is this vector a bar, b bar, c bar, like how do I write them? Let's see that. This is your 3D space, isn't it? So in your 3D space, if I move one unit along x axis, if I move one unit along x axis, then this small vector, this blue vector that you see, this blue vector so this blue vector, does it not look like a vector? It is a vector, right? What is this vector? Where is it starting from? It's starting from origin. Where is it going? It is going at 1, right? So its magnitude. Its magnitude is, how much is its magnitude? It's 1 unit. And what is its direction? Its direction is along x axis, right? You can clearly see that. Now the point is, this vector, this blue vector is called I cap, right? This blue vector is called I cap. What are the two specialities about I cap? The first speciality is it is a unit vector. That is why it is a unit vector. Why is it called a unit vector? Because its magnitude is 1 unit. It's a unit, right? 1 unit. And its direction is along x axis. That is the speciality about I cap. And I always represent unit vectors as caps. Remember, this is a cap, right? I've been representing vectors as bars. This is also a vector, but because it's a special vector called unit vector, it is represented as this cap. Similarly, j cap is a unit vector along y axis. Can you draw j cap for me on this diagram? So it's something like this. It starts from the origin, again 1 unit. So here it comes here. This is your j cap. Why? Because it's along it's along y axis and it is having a magnitude 1. Similarly, there is another vector called k cap. This is a unit vector along z axis. Can you draw this for me? Yes. So this is again 1 unit, right? This is 1 unit. This vector which is pointing upwards like this, right? That's 1 unit. And where is it pointing? It is pointing along z axis. That's why it's called k cap. So these are just notations. Remember, these are names given to these 3 vectors. The name given to this vector is I cap. The name given to this vector is j cap. The name given to this vector is k cap. Now let's see how we can use this information to create our components, because that is what our agenda was. So let's proceed with that. Let me make some space. Now coming to our agenda was to get this a bar, b bar, c bar. They were my components. Remember how a bar looked like? Remember how it looked like? It looked like this vector. This was your a bar, right? From 0 to 2. Here along y axis from 0 to 3, this was your a bar, this was your b bar, and c bar was from 0 to 5 along z axis. C bar. Now how can a bar be written as? That is my question. How do I write it? First of all, I have already given name to a vector I cap, right? What is I cap? If I draw a similar diagram, I cap is something which is of 1 unit and it is pointing along x axis. What if I do 2 I cap? You already know multiplication by a scalar. what it will do is, it will scale this vector, and this will be my new vector. The new vector will be of magnitude 2 units, right? 2i. If I take the magnitude of I cap, that is 1 because it's a unit vector. If I take the magnitude of 2i cap, it is 2, right? Because it is something like mod 2 into mod I cap, and mod I cap is 1, right? So 2 units, and because this lambda that you see here is greater than 0, that means this 2i cap is a vector which is pointing along x-axis and is having a magnitude of 2 units, right? Did you follow me? I had a vector a bar and I studied lambda a bar, right? Lambda a bar was a new vector which had a magnitude lambda a, isn't it? Now if your lambda was greater than 0, this new vector's direction was along a bar. What is my a bar here? My a bar here is I cap. And what am I doing? I am doing 2i cap. So my lambda is 2. What will be the magnitude? Mod 2i, which is 2. I have already shown. What will the direction of this 2i cap be? Because your lambda is greater than 0, that means it is along I cap. Because direction had to be along a cap if lambda was 0 and a cap is I, a bar is I cap here. And what is along I cap? It means it is along x-axis, because I cap itself is along x-axis. And this is what my a bar had to be, right? The a bar that I am naming is a vector of length 2 units and it should be along x-axis, right? That means this vector is 2i cap. Similarly, can you tell me what is b bar? I'll follow a similar procedure. I will take a unit vector along y-axis. What is my unit vector along y-axis? It is j cap, right? But I need a vector along y-axis which has a magnitude of 3, and this j cap has only 1. So what will I do? I'll multiply this j cap with 3 and plus 3 so that my direction doesn't get reversed, right? Because my lambda has to be greater than 0. If it is less than 0, then it will get reversed. But I want it along y-axis only, so that's why I'll multiply this with plus 3. And but the moment I do plus 3, I've got my vector b bar, because this has a magnitude 3 and its direction is along y-axis, because j cap is along y-axis. That means my b bar is 3j. Similarly, now that I know that the unit vector along z-axis is k cap, that means this vector c bar is phi k cap along similar lines, right? Along a similar argument. So I have finally got my components. I can write my OP bar as 2i plus 3j plus phi k. Remember, this and this. These three are three different vectors. This is a vector along x-axis. That's why it's called x component. This is a vector along y-axis. That's why, remember, it's called y component. This is a vector along z-axis, right? 5k. That's why it is the z component. So a vector, when represented in three-dimensional space, has three components. What if one of the components becomes 0? What if your you have something like ai plus bj only, right? If you don't have a k cap, that means that though you have x, y, z, you have a three-dimensional space, your vector is only in the xy plane, right? Your vector is only in the xy plane. And how do I justify that? This is your xy plane. Your vector has to be in this plane only, because its z component is 0. That means there is no projection on z axis. Now I am using the word projection again. Don't focus on the word projection right now. We will, once we enter the chapter directional cosines and ratios, we will look into what these components are in a different, with a different angle also. I'm not bringing that angle here right now, though you have already seen what directional cosines are, and it's also valid for this particular diagram and for any diagram for that matter. But for now, I'm not bringing up that topic because we'll anyway study that in detail. But for now, what we have understood is a vector is a combination of its components. And for components, I will use my reference axis. For 3 dimensions, I will use 3 axes. Sometimes you also have a 4-dimensional vector, right? Something like a 2i plus 3j plus 5k plus 7 w cap. W cap is some fourth dimension which we are not able to see, which we can't imagine, right? So you can have any number of dimensions. Depending on the dimensions, the vector will look like that. So, but usually in real life we use 3D vectors. So like we care about these three axes, their unit vectors, and how their unit vectors are used to obtain vectors along those axes, right? These are vectors along the three axes. I'll take the vectorial sum of these three, and that will give me the vector, the original vector of which these are the components, right? So now I hope you have understood clearly as to what components of a vector are. We will once again bring up, remember as we watch this video, we will once again bring up this components thing when we study directional cosines and directional ratios, and there we will give a new angle. We will give a new angle to this topic, right? So with this we complete components of a vector. Let's proceed with the further topics.